It says find the derivative if exists at negative 9. So f of x equals x plus 9 to the power of 2/3. And we need to find f prime at negative 9. Well, what's f prime of x? Take the derivative. 2/3, yep. X plus 9 to what power? Negative 1/3, right? 2/3 minus 1 is minus 1/3 times the derivative what's on the inside, which happens to be what? 1. Can we clean that? That's 2 over 3 times. Since that's a negative, you bring it to the bottom, becomes positive 1/3, and that's the cube root of x plus 9. 1/3 means a cube root. Now the question, what's the derivative at negative 9? At negative 9 is going to be what? 2 divided by 3 times the cube root, negative 9 plus 9, which is 0. What's the cube root of 0? 0. 2 over 0 does not exist. It says find the derivative if exists. If an answer does not exist, enter DNE. DNE does not exist.
I have a question. How come it's not 0?
Can't be. You're dividing by 0.
No, like from the start, if you substitute in...
That's not the derivative. If you plug in 0, that's the y value is 0. If you look at the graph of that function, the graph looks like this, and I think they gave you that one. This is the negative 9. The graph looks like this. If you plug in actually f of negative 9, you're getting the y value here, which is 0. That's what you're getting, but not the derivative. If you just look to the picture, the derivative is what? The slope of the tangent line. What is the slope from the left side? It's going to be negative. I don't care what the value is, going to be negative, right? What's the slope from the right side? Positive. They don't match. It has to be the same slope from both sides. Since there is no slope, the left does not equal to the right, there is no limit. The derivative is the limit. From the left side, that's a negative slope. The right side, positive slope. If you remember from the derivative, they have to be the same answer from both sides. Since they're not the same, I could have just wrote DNE without doing any of the work there. But what you're thinking, plug in negative 9 here, that does not give you the derivative. That's just the y value. The function is defined when it's negative 9. It's actually 0. But the derivative does not exist. I'll come back to this to put it back in. The other question is number 6. And 6, locate the absolute extrema. F of x equals 5 minus x, and it's from negative 2 to where? I mean negative 5, not negative 2. Negative 5 to 2. Now we need to find, we said the extreme is always going to be where? Either at the end point or at either endpoints or where the derivative what? Is 0. Well, or another one where the derivative might be what? Undefined, does not exist. In this case, does not exist because there's no fraction. So if you're going to have extrema, it's going to be either where the derivative is 0. The only time you have does not exist when you have a fraction or a square root negative number. So in this case, it's going to be either at 0, derivative is 0, or the endpoints. Well, let's take the derivative. That's a negative 1. Set it equal to 0. Is there a value that will make the derivative 0? No critical numbers, I think the book calls them. So in this case, your extreme is going to be just the endpoint because the derivative will never be 0. So what's the value of the function at negative 5? And what's the value of the function at 2? At negative 5, we have 5 minus a negative 5, which is what? 10. And at 2, that'll be 5 minus a 2, which is what? 3. So now we have the minimum. Where? At 2 comma 3, when x is 2, the y value is 3. And the maximum, or maxima, it's going to be where? At negative 5, and the value of that is going to be what? 10. That's your minimum and maximum. So this is the max, this is the min. Now this one's a fraction, it's the same thing. Look at the absolute extrema. Number 10. And what do we have? It's y equals 3x to the 2/3 minus 2x. The same thing. Find the min and the max at minus 1 comma 1. Well, we need the derivative. Let's find the derivative first. 3 times 2/3, that's a 2. X to what power? Minus 1/3 minus the 2. Now, can you rewrite that? That's 2 over what? The cube root of x minus the 2. The extrema, or the min-max, is going to be either where the derivative is 0, the derivative undefined, or the endpoints. So let's find the critical numbers. The critical numbers are where the derivative is 0, or the derivative does not exist. Let's see where the derivative is 0 first. Take the derivative, set it equal to 0. The 2 is 2 over 1. You can cross multiply. That's the quickest way to solve two fractions. 2 equals 2 the cube root of x. The cube root of x equals to 1. And what's x? Is that a 1? Here's the good news. The 1 happens to be one of the endpoints. So there's no additional points. See it? If that went from minus 1 to 3, then I have an extra point, the 1. If that went from 0 to 1.5, then I don't have the 1. It has to be within that limit. So that happens to be the endpoint. I'm good. What about the derivative undefined? Where is the derivative undefined? Nope. Not less than 0, just 0, because you can have a cube root of negative number, not a square root, right? So x is actually 0. When you have a fraction, the only time the fraction, we're talking about cube root here. So the cube root of a negative number is okay. So that's why when he said x is less than 0, if that was a square root, he's right. You can't take the square root of a negative number. But the fact is a cube root, you can take the cube root of minus 8, that's a minus 2. So the only time this is undefined when x is 0. And the 0 happens between the minus 1 and 1. So now when you test your endpoints and that point, one of them is going to be the maximum value, one is going to be the minimum value. So we have 3 points to test. We have the 0, we have the negative 1, and we have the 1. Again, f of x, so I can go to an, or y, whatever, is 2 times x to the 2/3 minus 2x. If I don't want to use a calculator for that, that reads to me 2 times the cube root of x squared minus 2x. So let's test it. When x is 0.
Isn't the original problem
Yes,
3x to the 2/3?
2/3. 3 is it?
I think so, yeah.
It is 3, thank you. Yep. Since I'm low here, I'll bring this one down because that's low, height-wise. Let me try the minus 1 first. You plug it in, what's f of negative 1? 3 times the cube root. When you take a minus 1, you square it, that's a 1. It's 2 times a minus 1. That's 3 plus 2, right? Which is 5. When x is 1, 3 times the cube root of 1, that's a 3, minus 2 times 1. 3 minus 2, which is what? 1. And when it's 0, 3 times the cube root of 0 minus 2 times 0, and that's a 0. Where's the smallest value? Here, that's your min. Where's your largest value? That's your max. So your max at minus 1, and the value of that is 5. Your min is at 0, and the value is 0. Yep. Okay. Any other questions? From chapter 4.